This is a Radiola RS, and it was produced about 1923. There's the lid, and this time it's got a metal plaque in it. And here's a much closer look at that metal plaque. The last patent date is 5/10/21. Here's a closer look at the front, and as you can see, it has two tubes, and they're both WD-11s. This is a closer look at the upper left of the radio. Now these tubes that are in here are not WD-11s. They've been rebased for this radio. In other words, it's a, I forgot what the tube is, but anyway, it's a more modern tube with a WD-11 base. But in this picture you can see the ground connection and the battery connections for the filaments. This one has 2A battery connections. Here's the other side, the upper right, and you can see the antenna connections, long wave and short wave. Now here's the bottom of the radio, and you can see the rest of the power connections, and the tickler coil, and the larger dial is for tuning. And you can see that this radio was made for RCA by Westinghouse. Now I have taken the radio out of its box, and there's a stamp in the upper left hand corner. Here's a closer look at it. Looks to me like it says US. And this sticker, which is a small one, that's on the bottom of the radio. Now here's the inside of the radio, and you can see the two tubes, and the transformer in the center is the only audio transformer in this radio. You can see the big coils in the back, and they both have a couple of coils that turn on the inside. One of them is the tickler and the other one is the tuning coil. And over on the right, that large fuse-like looking thing, that, believe it or not, is the grid leak resistor for this radio. Now here is a look at one end of the radio, and this is the tuning end. In other words, you can see the coil within the coil. That's the tuning side. And just below the grid leak resistor, that square item that's got 6 screws in it, that is the capacitor or capacitors for the antenna. Here is the view from the back of that large coil. And here is the other side of the radio. Now the coil within the coil, that is the tickler coil or the amplification coil, or it varies the amplification depending on how much it is coupled to those other coils. And below that you can see the power connections for this radio. and also the phone connections for the radio. Now here's another shot of the top of the radio. Now that audio transformer, I believe, has been replaced. I don't think it's the original, but it is appropriate for this radio. And we're going to be doing some testing, checking out all the coils in this radio to see if it may work for us. And this connection right here, this is the first tube of the radio. That is the plate connection that we're going to be using. And on the other tube on the left, right here, that is the grid connection for that tube. This is the wiring diagram for the Radiola RS, and it has a very similar architectural stamp to the other radiolas, 1 and 2 and 3 and 4 tube, that are regenerative. But I want to test the coils out in this radio before I put power on it. And it doesn't matter where I start as long as we get through all of them. So I'm going to start right here with the B+ connection. That will go through the primary of that audio transformer, and then through the tickler coil and a couple other coils, and to the plate of the first tube. So here is that connection with an ohm meter, and you can see that it reads 1,300 ohms. So that means that all these coils are good. Now the next one that I'm going to test goes through right here, the minus battery connection through the rheostat, through the secondary of the audio transformer to the grid of the second tube. And that is right here, and you can see that it reads 5,000 ohms. So this is definitely, on the audio transformer, a step-up transformer. So that means that the secondary and the rheostat are good in this radio. Now here are the other coils that I'm going to test. I'm going to go to ground, which is also the shield in this radio, and up to the connection between the capacitor for the antenna and the grid leak resistor. And that connection is right here, and it reads 5 ohms. So that means all these coils are good, which is very good news, of course. And that also should mean that when I put some good tubes in this radio and wire up the batteries correctly, this radio should receive some stations. While I had this radio open, I thought it'd be a good idea to ohm out the grid leak resistor, which is right here in the circuit. And the grid leak resistor reads about 3 million ohms. So that appears to be a good grid leak resistor. All the coils and the rheostat and the grid leak resistor all check good in this radio. So I'm going to look forward to hooking it up to power and an antenna and see how many stations we can pull in. Thanks for watching.